book that Sean and I wrote on learning psychology. I've prepared a lot of slides. It's a course I also give in Ghent, but I've tried to condense it still. There's more than 100 slides here, which of course I can't do in any type of detail, but I think it's good that I explain the framework and the idea behind the book, and then all the rest is simply filling in the framework for each type of learning. And that's not so important. There, I think it's best that I just really go through it very quickly, and if there's something that you want to know more about, just ask me. I can't guarantee that I can do many details on everything, but you can try and see what comes out. But first for the framework, so this is the book. Everything starts with the definition of learning, and so I define it as ontogenetic adaptation, which is basically changes in behavior during, as the result of regularities in the environment during the lifetime of your being. So it is adaptation, and you adapt to your environment, you change your behavior as a result of regularities in the environment. But what is unique about learning is that this occurs during the lifetime of the organism. This is, of course, a functional definition because behavior is a function of regularities in the environment. Now, one important thing to realize is that this definition implies that you cannot observe learning, because learning is a causal effect. It's the effect of regularities on behavior, and causality cannot be observed. So it's always an inference. It's always a claim that you make. So that's an important thing. Learning, the way I define it, is not real. It's in the eye of the observer, of the scientist. The scientist makes a claim about whether there's an impact of behavior on environment. And that's actually the core of the whole functional level. The functional level is always about the analysis of the scientist, of the person outside who's analyzing somebody else. Analyzing means trying to figure out what elements in the environment are determining the behavior of this individual, and then based on many observations in many individuals, you come out with abstract principles that you can then apply to many different situations. This is different from a cognitive psychologist. The cognitive psychologist tries to explain from the perspective of the person who is acting, because the cognitive psychologists try to look inside the person and see the causes within the person. So if a cognitive psychologist might, for example, say, yeah, but it's not the regularities that cause the behavior, it's the interpretation of the regularities that causes the behavior. And many of us find that really plausible, and it is really plausible, right? But that's a cognitive point of view, because you're looking from within the person, not as somebody outside of the person. Somebody outside of the person, a functional psychologist, would also say, okay, regularities do not always influence behavior. There are moderators, but those moderators are also looked in the current environment and the learning history of the individual. So the learning history means whatever that person experienced since birth. And that explains when regularities influence behavior. So it's also the functional psychologist doesn't say that regularities always influence behavior, just like a cognitive psychology would say that. But the functional researcher would try to find out what are the moderators in the environment, whereas the cognitive researcher tries to invoke mental mechanisms to explain when regularities influence behavior or not. And that's a really fundamental difference. And it's not that one is more correct than the other. It is simply a different way of doing science. You try to do science as an outside observer, or try to do science as trying to understand what is happening within the individual. Yeah, and that will be important this afternoon also, because behaviorism, of course, takes the first approach to science. Now, the good thing about this definition, so basically the book was also written to show people how useful this definition is of learning, because you can use the definition to organize different the whole literature on learning psychology, plus make new predictions based on this definition. And one of the advantages that you have this concept of regularity, because that's the really new, unique thing about my definition of learning compared to other definitions. Other definitions in the past have said that learning are changes in behavior due to environment, but I introduced the concept of regularity. Now, regularity is interpreted very broadly. That's anything that's more than one stimulus at one point in time. So even two stimuli at one point in time, like in one trial conditioning, you have one time the tone, one time the shock. Afterwards, the, the animal has fear for the tone. This is still conditioning. It's one trial conditioning. So it is still a regularity. So regularity means some kind of orderly event. It doesn't have to mean some kind of event that is orderly over time or that repeats over time. It's any type of orderly event. And then you can distinguish different types of regularity, and those different types of regularity correspond to different types of learning. So there can be regularities in the occurrence of one stimulus. One stimulus, for example, you can have a loud bang and you have a startle response. If you repeat the loud bang, your response to the startle will change. So you have a change in behavior. Your response to the loud noise changes from intense to less intense, and this change is due to the repetition of the stimulus. So this means that the change in behavior is due to that's your hypothesis, that's the inference you're making. It is due to the regularity, hence it is learning, and because it is one specific type of learning, namely a regularity in the occurrence of one stimulus, it's one specific type of learning, namely one example of an effect of regularities in the presence of one stimulus.
I have one comment or question. This definition of learning then could be used not only for humans, also for machine learning in a way, because they also learn based on regularities. But my second point is why the occurrence of two stimuli could be also a pattern of stimuli. So one stimulus is clear, behavior stimuli is clear, but why only two and not more than two?
Well, I'll start with the second one. These are three examples of regularities, so you can have more than that. I focus on these because these are the three that are typically studied in learning.
Okay. So there will be more than two stimuli.
Yeah, there could also be regularities between behaviors and behaviors. So these are the three examples of regularities. Second is, read my new paper in press in Perspectives on Psychological Science, which is learning in systems other than organisms, namely machines, genes, and groups. So indeed, that's a big advantage of this, because if most people would say learning is storing information in the brain. That is like the average of all the definitions you'll find on the internet and so on. Now, of course, what with systems like a machine or a robot that don't have a brain, or a group of people, they don't have a shared brain, or where do groups of people store their information, and so indeed, with this functional definition, you can apply it to any system. That the only thing you need to say is, what are the behaviors of that system? Do the behaviors of that system change? And if those behaviors of the system change because of regularities, then you can say that the system has learned. And that way once you've done that, then all of your knowledge about learning in organisms can be transferred to these other systems. Because you can check, does this particular robot show blocking or counter conditioning? Yeah, so everything we'll say now about organisms can then be examined also for other systems.
Yeah, can I ask you one thing? Isn't this definition of regularity too broad? I mean, I was wondering, what doesn't count as a regularity? Because we never experience one event of a multi-event, that's it.
Yeah, well, it only excludes one event at one point in time. So if you have, what it excludes is behavior. So you have, if I for the first time bang on the table and you show a response, that's not learning. It is because that's a behavior. Learning requires a change in behavior. So you at least need to observe the behavior twice, and be able to observe a change in the behavior.
But the regularity, I understand about the behavior, but if you bend, there is a regularity between your movement and the loud.
Yes, but the change in the, yeah, you cannot observe a change in behavior, that's the first thing. And it's not whether there is a regularity, but whether that regularity is responsible for the change in behavior.
It's a simpler technique. I mean, regularity is what produces a change in behavior.
Yes, but there are always multiple regularities in the environment, and you have to identify that regularity which is responsible for your change in behavior. Also, I don't see where the regularity is because there is, okay, you could say between the noise and the behavior. But in that case, if you repeatedly bang on the table, my hypothesis would be it is not because you repeatedly react to the tone, it is because of the repeated presentation of the tone. But remember, that's a hypothesis, that already illustrates that you're always making claims about what the causes are of behavior. So, for example, in a conditioning experiment, you have the regularity between a tone and a shock. It could be that the change in behavior that you observe is due to the repeated presentation of the shock and not due to the contingency between the tone and the shock. In that case, it's a different type of learning, because then it would be an effect of the repeated presentation of the shock, whereas otherwise it would be classical conditioning, the effect of the pairing of the tone and the shock. So it can be very difficult sometimes to determine, first of all, whether learning has occurred and which type of learning has occurred, simply because you are making causal assumptions. Now, the good thing about my definition is that you're making causal assumptions, but we have ways to test causal assumptions. We have ways to provide arguments for it, namely experiments. We manipulate things. And if we observe that manipulating one thing changes the behavior, but manipulating another thing doesn't, or controlling for something else doesn't, then we have arguments to say that, for example, it's classical conditioning and not habituation or something like that, or sensitization. But that's a very important point. You never observe learning. It's always an inference that you make, and you always have to have arguments for the claims that you make. So saying that learning has occurred is a claim, and you need to back that up with arguments. But it's easier to verify functional claims, to verify a functional definition, than to verify a mental definition. Because with the mental definition, for example, the storage of information in the brain, then you need to know what and where and how do I conclude that information is stored somewhere. What is that information? Where is it stored? How can I verify that? That's much more difficult than simply verifying a functional definition, but regularity influences behavior.
When you say that you observe a change in behavior, this can be also in two different organisms. What I mean is, like in rare exposure, there is the two events, the first in which the stimulus is exposed, and the second one in which we measure the reaction. So, as a scientist, I do see in the organism only the second behavior, but I can say that there is a change because I have another organism in which I measure the reaction to the first exposure.
That's a between subjects approach for testing learning. You have a group with one measurement. In both groups you only have one measurement, but in one group there is a regularity and in the other group there isn't. You can do it that way also. Because you can say, okay, I know from observing the other group that this change in behavior, that this behavior wouldn't have been there without this specific event.
So this is contemplated in the definition, the fact that I do not really need to see the change in that organism, I can infer it.
Yes, you need to say that there has been a change in behavior. Normally you do it within an organism, but in principle you can do it also between organisms. You could say the behavior of that organism wouldn't have been this way without that event. That is the core, basically, of it. And that's also the core of every functional definition. It says something wouldn't have happened without an event. So it is a counterfactual definition.
couple of questions which are just the opposite of what you were saying, the opposite in terms of extent. I would consider two things. First, regularity is directly claim about experience versus observe. Regularity is a regularity something that you can observe instead of experiencing in the first place.
Well,
because it's part of the learning.
There would always be a regularity. So even it could be a regularity between the behavior of a model and events in the on. Then you are not observing. Then there are multiple regularities, and you have to figure out what is the regularity influencing the behavior. Because a model can, for example, be startled when seeing a snake. You say there's a regularity between the snake and the reaction of the model. And this regularity can influence
so it's part of it.
Yeah, but the observer, the model, might have been afraid of the snake because in the past the snake has bitten the model. But it's not that regularity that is influencing the behavior of the observer. The regularity that is influencing the behavior of the observer is the model reacting to that.
But that opens up all kind of explanation of behavior.
Yes, and in the textbook we use observational conditioning as an example of how broad the definition is, because it can also include the observation of social, so of members of your own species, and it can also include even language, sentences. Sentences are also regularities. Those are words presented in a particular order.
The other question, again, is from a logical extension, not how much, but you say more than one regularity. But I would consider the possibility to think in terms of relative frequency or percent. But I mean, 1 out of 1 is 100%. So if you see only one thing, and that's what happens, that means you could claim that it's a regularity in terms of relative frequency. So only one, and that's after the side.
So I'll come back to that when I talk about operant conditioning. But you remember, this is always an analysis on the part of the observer, on the part of the scientist. So the scientist determines what is a stimulus, what is a response. When do we? This is the descriptive level that I talked about at ESCOM. It is the scientist organizing the world. And the world means the environment now, but also the environment in the past. So if the scientist could say this percentage of presentations, for me, is a stimulus. And he can define it that way by saying the unit of this class is that out of so many events, so many other events occur. So if the researcher says this is for me the stimulus, then the researcher can examine, does this stimulus evoke responses, and then it's a behavior. And if I repeatedly present the stimulus, does the behavior towards that stimulus change? So it's exactly the same as with an individual ringing of the bell, except that now you define the stimulus as something much broader and complex. And that's important to know. And this is like maybe the core thing. There's many core things, but really at the philosophy of science level, you cannot understand functional psychology without realizing that this is not about reality. Functional psychologists are not making claims about what the world really looks like. It's not about ontology. Whereas cognitive psychologists, they tend to say, I want to understand the real cognitive structure. Functional psychologists, they're allergic to ontology because they realize everything I'm doing is my analysis. I decide what the stimuli are. I decide what the responses are. I decide what regularities are. I even decide that there is a concept like classical conditioning. There is no classical conditioning. Classical conditioning is something that functional researchers have invented. And the only reason to continue, that's okay. The only reason why they use a concept like classical conditioning or any other concept that they use, the concept of a stimulus, anything that they use, is that they assume that this is useful for them, that it helps them to predict and influence the behavior of an organism. That is their ultimate aim. And for that, they would do anything, as long as it contributes to the aim of predicting and influencing. So I have a recent chapter which appeared in French, but the English version is also available. In principle, Skinner also says that that internal events should. He said that explicitly that covert behaviors you can also take them into account because it can help to predict and influence. So anything that helps to predict and influence is good for a functional psychologist. A functional psychologist doesn't care about what is real. Functional psychologist makes his or her reality. And if making the reality is useful, then it's okay. But you see, it's a mind shift for cognitive people. They are brought up with this idea we have to discover the real reasons of behavior and the mental structure and so on. This is a completely different way. So it's the functional versus cognitive psychology correlates with functionalism versus realism. But that's philosophy of science. So the different regularities, different types of learning. We've added complex learning as the joint effect of multiple regularities. So that's something new we did based on our definition, because if you say regularities are important, then you can say, okay, multiple regularities can be important. And that's how we came to the concept of complex learning. So it is always an inference, it's an assumption about the causes of behavior. And it can be difficult to determine what is the real cause of the change in behavior. The distinction between procedure and effect. So procedure is the descriptive level. That's where the scientist decides, this is for me a stimulus, I'm doing this. And so the procedure is in principle objective, because the scientist can explain to another scientist, this is for me the stimulus, that is for me the repeated presentation of the stimulus. So that's the procedure. And the effect is the impact. And impact is something causal, and you cannot observe causality. And then we come to the two approaches, so the functional approach and the cognitive approach. So functional scientists want to predict and influence, and to predict and influence, that's an important point also, you cannot influence the behavior without influencing the environment. I cannot directly intervene in cognitions, because cognitions are something non-physical. I can mess up the brain maybe, but then I still need to make assumptions about what brain areas carry which type of information. So you cannot directly vector make the nice distinction between the content of a representation and the carrier of information. So the content of information and the carrier of information. In principle, the same content can be present in different carriers. So information about the temperature in each different year over the centuries, that information you can find in a computer, in a brain, or in the rings of a tree. The rings of the tree is also a carrier of the information about temperature. So carrier, the content of information is independent of the carrier. Of course, you can have debates, it's not entirely independent. It's constrained by the carrier and so on. And that's why you can intervene in carriers, but you cannot directly intervene in content. So that's why functional people say the only way we are functional beings, so the only way we can change the behavior of somebody else is intervene in the environment. Yeah, if that's so necessarily, if your aim is to influence the behavior of others, you need to know what the environmental causes are, because that's the level at which you need to intervene. It might be nice to know about cognitive causes, but even a cognitive person cannot directly intervene in the informational content. They can only intervene in the physical reality, whether it is the brain or the environment in which an organism lives. So for functional psychologists, this approach, trying to find out how behavior is a function of the environment, is a necessity. It's not, they cannot do anything else, because in order to influence, they have to understand how the environment influences behavior.
One
Yeah.
stupid question. Why do you use functional approach and not use the old term behavioral approach?
Because behavior emphasizes behavior. It doesn't emphasize function. So, yeah. So there can be many approaches that focus on behavior, but it is actually focusing on the fact that behavior is a function of environment. That's why. And also, of course, behaviorism is a very loaded term, and there are many misconceptions about behaviorism that Jamie will talk about this afternoon, I'm sure. That's why. But it's not a perfect term because most cognitive people understand it as functional in the sense of functional for something rather than a function of something. So we always clarify that we use functional in the mathematical sense, just like this is a mathematical expression. Behavior is a function of the environment. It's not that behavior is directed at or is a function for to reach something. It's not teleological, but it is functional in the mathematical sense. And the functional approach, so it must focus on the relation between environment and behavior. It tries to understand this behavior, and in terms of learning, it's understanding how regularities influence behavior. And this is then, the main task is then to, first of all, discover when does environment influence behavior, to understand the moderators of it. And the second task is to use this knowledge and then make it as abstract as possible. And that's another difficult point to understand. That is the analytic abstract of the art. Maybe, so there are 5 groups of moderators. If you do a learning experiment, you always need to have stimuli and behavior. You need to observe behavior. You need to have an organism, a context in which you do your study, and then you need to decide what does my regularity look like. And these are the 5 potential moderators of learning. And in our book, we organize the whole literature of learning based on those 5 moderators. So any experiment in learning psychology manipulates at least one of those. And hence you can organize the whole literature with that. But so now, functional knowledge, basically if you do an experiment, you are being a functional researcher because you have a dependent variable and you have an independent variable. And what you try to establish in an experiment is whether the dependent variable is a function of your independent variable. So every experiment you have done is functional research. But this is what we have termed effect-centric functional research, because you focus on moderators of the specific effects that you're studying. For example, you could have the Stroop effect or the color word Stroop effect, and that's an impact of the congruence between word and color on reaction time. Now, of course, there have been many studies on the Stroop effect, and those we know a lot about the moderators, but typically the knowledge is restricted to that one effect, because you speak in terms of one effect. You have color and words, and it's an effect invented by Stroop. The same with negative priming. You have an effect of a prime on a target, where the response to the target is slowed down. So these are most of the effects that cognitive psychologists speak about. Most of those effects are formulated in words that are more or less specific to the effect that you're studying. So this is what we call effect-centric functional learning. You're doing relations between behavior and environment, but you phrase those findings and those procedures in terms that are specific somehow to the effect that you're studying. Now, what behaviorists do, so, and this is what we have called, or what is called, the abstractive, analytic abstractive, where is it? Somewhere. Yeah, the analytic abstractive functional approach. They try to formulate effects and functional knowledge in concepts that that are not, that do not refer to the specific stimuli that you use or the specific effect that you're studying. What they try to do is to formulate their knowledge by referring to everything in their analysis in terms of the role it plays. So a functional analysis basically means what is the function of the different events in the environment for influencing behavior. For example, in Skinner's rat, you have a tone, and if the tone is present, the rat presses a lever in order to get food. You can talk about this in somebody who's interested in food digesting, for example. This would be an interesting effect. But for that person, it's enough to talk about lights, lever pressing, and food, because they're interested in food. But a functional psychologist is not interested in food. They're only interested in the function of the food. And the function of the food, in this case, is to increase the frequency of the behavior with which it is paired. So we refer to the food not as food, but as a reinforcing stimulus. So what is a reinforcing stimulus? It's a stimulus whose role is to increase the frequency of the behavior it is paired with. The same thing with the light. Behaviorists don't talk about the light, they talk about the discriminative stimulus. Why do they use this word? Because the light has the function to influence behavior, because it indicates when the behavior will be followed by an outcome. So that's the definition of an SD. It's the role that stimulus has. And everything in functional psychology is formulated in terms of the role that events have, in the relation between environment and behavior. Okay, that's a really important point, because that's why they use them. They don't use these terms because they are abstract as such. They use these terms because they are abstract in terms of the role. So it is really like an abstract painting. You can look at the human being, and you can then abstract out the geometrical shapes in the body, like cubist painters would abstract out the geometrical shapes. That's abstraction on the basis of geometrical shape. What behaviorist does is that they look at an environment-behavior relation and they abstract out the role of things. That's what they do. And of course, why the role? Because the role tells them if I then influence this, then that will happen. If I manipulate something with a particular role, then this will, as a result, change behavior, because that stimulus has a role. So I try to influence that stimulus, and that will influence behavior.
So, in a way, in regulative conditioning, the role of positive or negative pictures is, in a way, so the effect is a kind of indirect effect because of the informative role of negative and positive.
That's already informative role is.
I think useful role. I'm not sure yet.
So the US is simply something that you pair with the CS, and of which the pairing is supposed to change the behavior. So the CS I would define as the stimulus for which you examine whether the reaction to that stimulus changes as the result of the CS-US pairing.
Yeah, I understand, but from a functional perspective, the food is a kind of unconditional stimulus in a way, and the US is also kind of unconditional stimulus. So why back offers from a functional perspective? This kind of functional, like reinforcing people to approach positive things and avoid negative things.
I'm not sure I understand what you do. So in this case, the food is referred to as a reinforcer because it increases the frequency of the behavior that
so it was an increasing.
So this is an operant situation. Whereas CS and US, those terms are used in classical conditioning, and the CS is the thing for which you examine whether there is a change in reaction, and the US is the the thing that you pair with the thing for which you will examine. Then the cognitive approach, they're not interested in the environment-behavior relations as such. They want to know the mediating mental mechanism. So how is it possible that the pairing of stimuli, for example, changes behavior? How can that be? What is the necessary intermediate step? That's the mediating mechanism. And this mechanism is formulated in terms of information processing. That's why it is a mental mechanism. So they are not interested in not the functional relations as such. They're interested in explaining those relations in terms of mental mechanisms. And why would they do that? Well, have you ever asked yourself that question? I'm not sure any student of cognitive psychology is told why people are studying mental mechanisms.
Because if you know which mechanism are, you can intervene at the level of the mechanism.
Okay, so you're doing, because there are two. First of all, in principle you could say, I'm interested in this. I'm interested in the mechanism as such. And that then I would call a cognitive aim. Because your aim is to understand mental mechanisms. But if you say my aim is to then use this knowledge to influence behavior, then then you're in essence a functional psychologist who's using mental theories as a tool to improve prediction and influence of behavior. Now, I think many cognitive psychologists, if you would ask, would say that they're interested in ultimately influencing behavior, but this is not, first of all, very rarely made explicit. I see it in very few textbooks on cognitive psychology. I don't hear it in lessons about cognitive psychology. And second of all, if this is your aim, so because I expressed in this figure, so you have in the psychological space-time continuum, you have a vortex where people are attracted to the cognitive approach, and you have a vortex where people are attracted to the functional approach. And the assumption often is of cognitive research that by engaging in the cognitive vortex, there is this secret shortcuts to the functional part, where it will help you to influence behavior and to better mankind ultimately. But this is, of course, an assumption. And I've seen people in my own environment, I've seen myself engaged in this idea for 20 years, and ultimately, nothing comes out of it. Nothing helps me to predict and influence behavior. So this is an assumption that you make, but you need to verify this assumption.
Yeah, the cognitive behavioral psychotherapy is entirely based on this assumption.
Of which?
Cognitive behavioral psychotherapy.
And it's based on what?
On this idea of
changing beliefs.
Changing beliefs.
Yeah, but
to change.
But then you're seeing beliefs as covert behavior.
Yes.
It's not about mental mechanisms.
Yeah, but there are some internal. It's difficult to study without from external perspective.
Well, and that's I think if you then look at what cognitive psychology claims to have contributed to functional psychology, most often it can be seen as at the behavioral level rather than at the level of understanding mental mechanisms.
So this is very philosophical point, but I imagine that actually you may not be just interested in predicting and controlling behavior. Imagine that, like, you're also interested in understanding.
There's a next level, which are your values. So what do you want to achieve with predicting and influencing behavior? I'll just wait a second and then I would prefer the windows to be open. Daniele? I would prefer the windows to be open and I'll just
stop myself. That's okay.
No, I'm using behavior now. I'm talking.
The point is, my point is, imagine that we perfect machine learning, and we have a machine, we build a machine that learns a lot of how people work, and I give it to you. And you can input will allow you to predict and control behavior, but I don't think that you would be happy to learn. You would like to have a simple rules. So you also want to understand behavior.
In principle, no. Because the goal is purely pragmatic. If you go beyond that pragmatic goal, then there is another goal, and then you have to be explicit about that other goal, and you need to specify what do I need and what is that goal, and how can I test whether I am approaching that goal. And those are two things that I think cognitive psychologists do way too little. They don't specify enough what their goal is, and they don't specify how they can determine whether they are approaching the goal. And that's also why people really don't test. They don't test whether what they are doing is leading them to the goal that they have, because they don't make explicit that they want to influence behavior, and they don't test whether what they do helps them to influence behavior. And then you get into a science of hypes. A science where there is a group of people that come together in the context of a particular effect, like negative priming or evolved conditioning. And then you have this society of people who reinforce their own behavior. And the only output that you see in 20, 30 years are papers in academic journals. That happens a lot. That's what I see in cognitive psychology a lot. And then suddenly people lose interest in a phenomenon and they switch to another phenomenon, and the same phenomena repeats. There's 10 years of hype, and then after 10 years, then you see the decline in interest. And nothing has happened except for papers. And I'm not saying that this is always the case. There are fields like memory researchers, those who do like witness identification things and so on. There is an organization called Practical Aspects of Memory. They really do engage, but they're explicit about it. They say we want to apply our knowledge about memory, and then they test whether this is useful or not. Does a certain line, they won't do research for 10 years on something, only to then say, no, they'll check. They'll always verify the assumption that this will lead us to better influence.
So if I understand correctly, the point is you want to have a performance indicator of what you're doing as a field, and then you say the other people don't have, like people don't have these performance indicators, but controlling repetitive behaviors are quantifiable, and so you can track your progress as a field.
Yeah. You have to, as a field, we need to be more explicit about the goals that we have, and we need to be more explicit about the criteria we use to determine whether we are approaching that goal. And that's it's so evident, because science is a goal-directed behavior, and every goal-directed behavior is possible only if there is a goal, and if you can assess the discrepancy between your current state and the desired end state.
That part I like.
So it is so ironic to see, I think, that science doesn't operate in a goal-directed way. And I must say, functional psychologists have this as their philosophy, but they're also not perfect in doing these things. For example, they would close themselves because they say, we are the only good guys. So, and they will then not look at what other people are doing, whereas this could help them to become influenced. So they're also dogmatic. Their big limitation is the dogmatism, which is very strange because they are pragmatists. So why would they be dogmatists?
Just following on your goal-directed behavior. Science has goal-directed behavior. Probably is the problem. I mean, it's that sometimes you're in the goal is to budge, or to do other kind of things like this. So the question becomes whether these goals are lined up with other types of goals. Great.
Yeah.
Nothing is not about that.
Anyway, I'm really annoyed about the fact that we train scientists. We claim to train scientist practitioners. That everybody who gets a master's degree in psychology is a scientist or a scientist practitioner. But we don't teach our students what science is. It's like giving diplomas to plumbers without telling them what plumbing is. So that I think it's really absurd. Either we have to stop claiming that we are training scientists, but if you train somebody to be a scientist, you have to have courses on what science is. Yeah. So one example to again clearly illustrate the difference between cognitive psychology and functional psychology. We all know the phenomena of latent learning. So on day one, we put a rat in a maze with output, so the rat explores the maze. The second day, we put the rat in the same maze, but now there is food on a certain location. That rat who could explore the maze in the first day would find the food very quickly. A rat who doesn't have the prior experience with the maze finds it much more slower. Cognitive psychologists have said this is the proof for the existence and the importance of mental events. Why? Because they say, how else is it possible that the rat is quicker on day two because of the experience in day one? The experience in day one has gone, so the experience in day one can no longer be the direct cause of the behavior of the rat on day two. Now, what this reasoning hides, what is implicit in this reasoning, is that cognitive psychologists always want to have an immediate cause. They are thinking in mechanisms, and just like in a clock, you have one, how do you call it again? Yeah,
no, we call it
yeah, but the things inside, one rotor.
It's a common.
Yeah, but I mean it's the rotors. One rotor puts another rotor in motion. Huh? You know what I mean? It's with those. So they think in that way, really like physical mechanisms. There always needs to be. I don't know the word, so I couldn't. There always needs to be an immediate cause. We call it contiguous causation. Here and now, one thing needs to put another thing in motion. And they make exactly the same assumption with mental mechanisms. So for latent learning, there also has to be a cause in the here and now. And because the event was in the past, the only thing that can be the cause here and now is a mental representation of that event. So somehow information is stored, and this information on day two functions as the immediate cause of the behavior of the rat. It causes the rat to find the food very quickly. So cognitive psychologists think in terms of contiguous causation, immediate causation. Whereas functional psychologists think about causation in a functional sense. For them, causation merely means that behavior is a function of environment. It doesn't matter how much time there is between the environment and the behavior, as long as the behavior wouldn't have been there without the event in the past. So latent learning is no problem at all for behaviorists. Because a behaviorist can simply say, the fact that the rat is quick on day two is a function of the exploration on day one. It makes perfect sense. It's only if when you start thinking in mechanistic terms that this becomes a problem. Only then do you need to assume mental representations that can function as the immediate cause on day two. And this is, I think, a good example because it's so well known and it illustrates so well the fundamental difference between a cognitive approach and a functional approach. And I've now made the difference in many ways. I've made the difference in terms of goals. That's the most important one because all the rest comes out of it. So what is the difference in terms of goals? Then the difference in terms of mechanistic versus functional, the difference in terms of realistic versus pragmatic. Those are all distinctions between a functional approach and a cognitive approach.
In this case, it is obvious that the rat that has experienced the way.
Yeah, for the airplane.
But I think there's a lot of activity
Yeah.
So it's obvious that the two basics are different. Maybe it's not that they have a marginal in their mind, let's say it can be, but they have to be different. So it seems that for the functional psychologist, doesn't he or she doesn't care what is the difference that they have now.
Yeah, they don't care about the mechanism because they say that what I need to know is what it is in the environment that influences the behavior. So as long as I know that, I don't need to know why, what comes in between. What cognitive people always says is that, yeah, but knowledge about the mechanisms can point me to new ways of intervening in the environment. That's true. And I would say to behaviorists, if mechanisms can help you identify new ways of intervening in the environment, use those mental mechanisms. But you can only use them as a tool. They'll never engage in trying to find out the real mechanisms. They will only do it just like many cognitive people claim that they're doing. They would engage in the mental mechanisms as a kind of proximal goal, a goal, intermediate goal, because it might help them with the ultimate goal of predicting and influencing. So I think you can do it. The reason why, so Skinner, I have it on my phone, in his book, 53 book of Science of Human Behavior, he actually says it would be nice to know mechanisms because then we have new ways of intervening. But he says we are so far away from knowing those mechanisms that it is better now not to lose ourselves in the search for. And he was looking, to be honest, for physical mechanisms like neurological mechanisms, not mental mechanisms. But that's the reason. A real functional psychologist, if mental mechanisms are useful for influencing and behavior, they should.
So I agree with everything. Could you just see this, for instance, why behavioral cognitive therapy they try to work? I mean, they think that the mechanism is belief that is mediating the environment and behavior. So yes, the environment is having an effect on behavior. That's okay. But you know, this is passed by people from within. So they could think, okay, we are trying to change mechanisms because this will change.
Yeah.
And they are not entirely unsuccessful.
Yeah. I'm preempting now, I think, things that Jamie will say. But behaviorists, in principle, accept behavior mechanisms. So one behavior can be the stimulus for another behavior, and you could have chains of behaviors. So that's behavior mechanisms. The only problem that they have with that is their belief that engaging in those mechanisms will detract attention away from predicting and influencing. You might get caught up in trying to document the mechanism and you lose sight of the fact that you want to influence. And that's also, Skinner never fundamentally disagrees with mechanisms. He just argues it is not productive, it does not serve our goals. In the end, in his later years, I must say, he became really dogmatic. And I can't follow him in the sense where, okay, I can follow him in the sense that cognitive psychology is a very difficult science to do, but to declare it unscientific, that is a step too.
I was wondering, for example, there are mechanisms, like neural mechanisms that we do understand. So you take a mouse in a maze, then, for example, you spray it with amphetamines. We know that amphetamines increase receptor, reduce hunger, and so the mouse, for example, will not be conditioned as well as without amphetamines. But the point is a functional psychologist completely disinterested with this kind of mechanism?
No. So the brain belongs to the environment. It's physical. The difficulty comes when you start mapping the brain onto informational content. So that's a step too far. But the brain, you have something like behavioral neuroscience. And that's neuroscience that doesn't refer to mental constructs. but only to environment behavioral relations basically as mediated by the brain. This is in principle should be acceptable for a behaviorist. Again, under that restriction that you should take care. So Dermot, a former colleague of mine, said that behaviorists are chained to their goals. The real behaviorist should say, okay, my goal is to predict an influence. And you can maybe touch some things to help you, but you should always be chained to your goal of predicting an influence.
Yeah, the point is you don't need to know the causal pathways that leads between internal to the brain, that leads from amphetamines to not pursuing the food. Your behavior should just be interested in the function. So adding amphetamines produces this effect and removing amphetamines produces that.
And remember, mechanistic thinking is also without a bottleneck. You can always go from the neural level to the chemical level and then the atomic level and whatever. So that's also the thing with mechanisms. Mechanisms are always situated at one level, and they're always embedded in other levels.
I was wondering maybe if this can be framed also in another way that is more complementary between the two figures, like basic science and translational science somehow.
Basic science and
translational science over applied science. So somehow functional psychology is more related to something that needs to be done here and now.
I see your point, but the problem with that is, okay, what is basic?
So let's try to translate in another word, like in physics. You have theoretical physics and applied physics. It's strong, but
it's a difficult discussion, and I don't think it maps on completely because you can really say it is a basic science to understand. They also behaviors makes the distinction between experimental analysis of behavior and applied analysis of behavior. So they do that. For them, applied means you're dealing with real world problems. Experimental means you're studying behavior in a lab. But in principle, both are the same. The lab is also the real world. It's simply a confined world. Yeah. But it's a long discussion on its own. And then, Jamie will go into this also. There are still strong behavioral movements, behavior analytic movements. And then, what is the functional cognitive framework is that. So what I focused on until now, is to make clear the difference between the two approaches. But that's important to realize that fundamentally different scientific approaches. But that doesn't mean that they cannot help each other. It's once you realize that they are fundamentally different, then any competition between the two stops. It's like saying, I'm doing psychology and that other person is doing sociology or physics. It's a different way of doing science, different scientific goals, and that leads you to do different things. But it's on very related subject matters. The functional psychologist wants to understand, predict, and influence behavior by understanding regularities in the environment. But the cognitive psychologist is interested in the impact of regularities on behavior. So the phenomenon that the cognitive psychologist is studying is the subject matter of functional psychology. It's simply that cognitive psychology then wants to understand the mental mechanism. So they are fundamentally different but intrinsically related to each other. And once you realize that, then you know that these different levels can strengthen each other. Functional knowledge can constrain mental theories, and mental theories can provide new predictions for functional knowledge. Now, if I show this to behaviorists, they say, well, but I don't believe in that. I don't believe in that. And then I say, well, it's just a matter of proof. Let's see. At least give it a try, rather than be dogmatic about it and say that it cannot succeed. But even Dermot, for example, wrote a paper saying, no, and then of course you have that's the effect first mental process conditioning as an effect is not the same as association. So then the book basically has 5 chapters. The 3 traditional types of learning, effects of non-contingent. This was translated from Dutch, and for some reason, stimulus is translated into incentive. incentive it's stimulus presentations. So effects of non-continuous stimulus presentations, classic cognition, operant conditioning, and then we have a chapter on complex learning, which I think is really important because this brings learning psychology away from this idea that learning psychology is about simple forms of learning. And you often, it's about conditioning, it's a simple, basic form of learning. No, learning psychology is about all learning, also complex learning, even language, learning via language. And that's what we try to do in chapter 4 is to create a bridge between traditional learning psychology and then what people would say very complex phenomena like language and learning via language. But I don't have time to go into that today. And because of the influence I gave you, we also added a chapter on applied learning psychology, in which we make the point, cognitive learning psychologists, please let us know what you have contributed to application. Because we couldn't identify anything. That there are like the Boughton theory of extinction maybe, and then inhibitory learning, but even there it's like very unclear what, anyway, so most of the applications from learning psychology come from functional psychology. And that's really for me, it's not, like this is not saying let's stop doing cognitive psychology, it's like be aware of this. And you've been doing 40, 50 years of models of cognitive, of learning psychology, which are very precise and can make very clear predictions. But which of those predictions have meant anything outside of the lab? And in each chapter we separate functional knowledge and mental process knowledge, which is for us really fundamental, because you have to keep these two levels separate. You have to keep knowledge about moderators separate from knowledge about mediators, because otherwise you will start to think about moderators in terms of mediators. For example, blocking. The term blocking is an effect in learning psychology. As I will say later, it's basically simply about redundancy in contingency. But by calling it blocking, you refer to a potential explanatory mechanism. You say that learning is blocked so that you do not learn information. Blocking is one example of a name for a moderator of learning that refers to an explanatory mechanism. Also here, we have to keep these two separate. If you look at textbooks in learning, they will explain blocking in the context of the Rescola-Wagner model. Because Rescola-Wagner was the first model to predict blocking. But blocking, you should be able to explain and describe this independent of any theory. Because otherwise you start mixing phenomena with theory, and then if the theory is discredited, your phenomena will be discredited, and so on. Okay, so shall we have like a 10-minute break now? Oh, no, we have coffee, real coffee breaks. 15 minutes. So we have still have 15 minutes. Okay. So now I'll go really quickly, because I'll just go over each chapter. So the first type of learning are effects of the regularity in the presence of one stimulus. The best known example is habituation. You have a stimulus like a loud noise evokes an orientation response. If you repeatedly present the loud noise, the orientation response will decrease in intensity. This decrease in intensity is a change in behavior. If you say that this change in behavior is due to the repeated presentation of the loud noise, then you said that learning has occurred. More specifically, you say that habituation has occurred. Habituation is one example of an effect of this repeated presentation of stimulus. Habituation is characterized by the fact that the behavior becomes less intense, so there is a decrease in intensity. Sensitization is the exact same, but then there is an increase in intensity. So both habituation and sensitization are effects of the regularities in the presence of one stimulus. The difference between the two is the direction in change behaviors. There are increase or a decrease. So here you get the first example of how the, I don't think I have the slide here with me, but how the universe of learning effects can be subdivided in types of learning based on the type of regularity. But within each type of learning, there are further subdivisions based on a variety of criteria. One of those criteria is the direction in the change of behavior. For example, sensitization is an increase due to repeated stimulus presentations. Habituation is a decrease. And again, I would like to emphasize this. All of these concepts in learning psychology, we can define very precisely. In that sense, I think learning psychology is a unique subject area in psychology, because in most areas of psychology, you'll get endless debates about what core concepts mean. Whereas in learning psychology, because we define everything in terms of role and in terms of observable factors, we can be very clear about what our concepts mean.
I wonder, how do you conceptualize habit in this context of repetition?
Okay.
Without code, I mean, I'm not saying habit in the sense of content or not content. I'm saying habit in the sense of tendency to repeat behavior further. There's an automaticity component or lower necessity of conscious control.
Well, it's one
repetition.
Yeah.
You talk about habituation, talk about sensitization. How would you classify it?
No, it's not. There are different ways to define it. In learning psychology, it's not defined in terms of repetition. It's simply defined as an operant behavior, so a behavior that used to be a function of its outcomes, but that now no longer is an function of its outcomes.
Repetition or something like that? Because
repetition is one of the moderators, but it's not the defining element of a habit. The defining element of a habit within learning psychology is the fact that it is not sensitive to, it's not controlled anymore by its outcome, whereas previously it was controlled by its outcome.
So from this perspective, I mean, there is some other literature, limited literature in social psychology, health psychology, which they say, you need to repeat the behavior 50 times, 40 times, it becomes habitual.
Well, then first of all, it's not clear what they mean with habitual. So they have to specify then what they mean with habitual.
Let's say to simplify.
And
because more likely to be.
It's not. For learner psychology, it's an empirical question. With beyond any doubt, moderated of habitual behavior in the sense of behavior that is no longer sensitive of the outcome. Repetition is moderated, but is it a necessary? Could it be that you get automatic behavior based on one presentation? In principle, yes. Instance models of memory, for example, have predicted and demonstrated automaticity based on one experience. So I would not call it the defining element. And whether it is that or not is a semantic discussion or an empirical discussion. But at least in learning psychology, people have opted for that definition of an operant behavior that is no longer a function of the outcomes that it used to be. Habituation depends on the nature of the stimuli. So let's pay attention to the fact. So in each chapter we first discuss functional knowledge, knowledge about moderators, and we group this in the 5 groups of moderators. The first is the nature of the stimulus, and you see that for neutral stimuli, habituation goes quicker than for affective stimuli. We see that for very intense stimuli we get sensitization rather than habituation. And it's even the case, and then you can also look at the impact of the nature of the behavior. So what is the behavior that you observe? Your choice of behavior to observe also determines what you find. So the choice of the observed behavior, the nature of the behavior is a moderator of learning. It determines when or whether you will find learning. So for example, if you would use heart rate as your dependent variable, you get different things than when you use skin conductance as your dependent variable. So the choice of the behavior you measure will determine when and whether and when you find conditioning. So the type of behavior is a moderator of habituation.
I wonder whether it's useful to define what behavior is for the functional.
Well, a behaviorist would say behavior is anything the organism can do, but somebody who's dead cannot do. Now, this is for me a very unsatisfactory definition, but I have proposed a definition in my new paper in Perspectives. I would say that behavior is the impact of a stimulus on the states of an organism. Now, I could talk hours about this definition alone because it has many implications. So
it's a one sense because some people say, okay, heart rate is not.
Well,
but you could say that it's behavior because you have a definition. Just
so behaviorists also would say an organism has a heartbeat and a dead organism doesn't have a heartbeat, so it's a behavior. Yeah, you can have fundamental, but behavior is not just movement of muscles. Behavior can be physiological responses, brain responses. It can even be conscious thoughts. So again, the question for a functional psychologist is not, is this really behavior? But is it useful to think about this as behavior? Does it help me to predict and influence when I think about brain activity or heart rate as a behavior? Or conscious thought? The question for Skinner was not, is conscious thought behavior? But can it be useful to think of conscious thought as behavior?
I was thinking, like the development of gas allergy, whenever the organism is exposed to this, would it be learning?
It can be learning. You first have to determine what is your system. Because you can, even when you have an organism, you do not necessarily have to look at the organism as a whole as the system that behaves. You can also look at parts of the organism as the system. That's a really interesting one. I think nobody has explored this yet. But there are like studies on the spinal gland as a system that can learn. But in principle, you can look at your genetic material and analyze whether it learns. Or your pulmonary system. And that was an idea I had recently. If you learn to play an instrument, maybe it's more useful to think of some musculatory system as learning, rather than you as an organism learning. It's like saying, no, am I learning? No, I'm just creating the conditions for my muscle memory but yeah. Anyway, so you need to decide what is your system, what is your behavior, does the behavior change, and is it due to regularities? That's the only restrictions we have for learning analysis.
Just one slide back. When you say, for example, very intense stimulus, is it something, I mean, referring to the physical properties of the stimulus, or to, for example, affective intensity the person can perceive?
It's also, that's another really, indeed, like intensity and so on. Yeah, I'm not sure whether there's a good technical definition of that, but yeah, it's like positive and negative, aversive, appetitive. There is no good functional definition of that.
So you get back essentially to a cognitive inference, so something that is...
No, a functional psychologist can only say that something is a reinforcer after the events have taken place.
But then it's a circle, for example, with this idea you would define intense stimulus as the one that moderates positively the...
Well, yeah, an intense stimulus could be, based on this, I say that this is an intense stimulus because it leads to sensitization.
Exactly, but then it's circular.
Yeah, but then it depends on, yeah. It has an element of circularity in it, but remember, like with reinforcers, it is, they say this stimuli has functioned as a reinforcer. That's what they really say. It has functioned as a reinforcer. But based on what the functions that things have had in the past, I can make predictions about what the function of those things will be in the future. I assume that functions stay constant over time, or that I know what moderates their functions. So based on, yeah, so when I say something is a reinforcer, then I'm simply saying it has been a reinforcer in the past, and hence, if I use it again in the future, probably it will again function as a reinforcer.
But what I mean is, for example, you have a positive or negative picture, and you know the effect of a positive picture and of a negative picture. Then next time, you assume that another positive picture will have the similar effect. Then what you do is essentially assuming that because your feeling is this is a positive or negative picture as the one before, but then you're using your own, I would say, your own feelings.
Well, so we have no technical way of doing that. So this is a shortcoming, but I think it's a shortcoming for everybody who uses this concept. So at least if you're really pure in your functional approach, you would specify this. You would say the basis on which you decide that this is a positive stimulus and that is an intense stimulus. You should specify that. For example, by convention or based on norms. But you cannot give a technical definition.
Two comments. First, in terms of content, could this be a model for positive stress disorder? Something which the same stimulus gets repeated, and every time the very intense reaction, no matter how many times it is repeated.
And that's, again, a topic of a whole lecture as such. What is a model? What is an experimental model? Saying that a learning effect is a model of a certain disorder or phenomenon is saying that these things are functionally the same. This means that the behavior is a function of the same things, like repetition of a stimulus, that the moderators of those things are also the same. So that's saying that sensitization is a model of, what were you saying?
Post-traumatic
stress. Yeah, post-traumatic stress. If you say that, then basically you're saying that whatever I know about the moderators of the nature and the moderators of sensitization will help me predict and influence traumatic stress disorder. There's no assumption about similar mechanisms or anything. It's simply a function of it. Just like classical phobia, classical conditioning is a model of phobia. Then you're saying that the behaviors are both functions of parents, and the conditions under which the parents lead to behavior are also the same. There's a paper that we have in behavior research and therapy.
Second question, has anyone thought about developing a new area which is could be called Bayesian functional psychology, which basically would approach like Daniel did, like the words, how much information I need to stop and say, this is positive, and from that point on to say, okay, I take my risk. As a way to break circularity, because of course if you wait till the end, it's trivially simple, it's positive, so now to school. But you could say, okay, I need to get as much information to the reasonably confident that I will make some mistake. But that's life, that's science.
As long as you are explicit about this, I think it's okay. But you need to be, you don't need to fall into ontological traps. You don't need to start saying, and because I have this, I now say this is a good thing.
No, it's a potential. But it's about the extreme.
It's simply what you described as a decision aid.
That's right, just about this case, just to introduce that is basically his observation can be afterlife when he said, yeah, but then you have to interpret yourself how much positive is that one. And I say, yeah, that's very probability. You believe that it's the same, you assign a certain level of probability.
That's what factors. This is what we have to say, okay. I can make my bet.
You can make prediction, functional prediction using that approach that is reasonable and that's not mistake.
So I'll just finish up this chapter. I can do it in 2 minutes. So you have stimuli are a potential moderator. The behavior you observe is a potential moderator. The nature of the organism. So you typically you can look at humans, but you can look at pigeons or rats, and you can also look at plants. Plants are also organisms, and they show. There's evidence that they show behavior. This This is slime mold. So it is a fungi, basically, and it moves and it behaves and there's evidence that it shows habituation. The broader context is, do I repeatedly present my stimulus in a noisy context? That can also moderate the impact. And then, what is the regularity? Because does it mean to say that you repeatedly present the stimulus? How far apart are the stimuli? How often do you present? And those are all things you can manipulate and that can moderate. And so this is the moderators. That's what we call the functional knowledge. I haven't said anything about mechanisms of learning. It's all about moderators. And now I start talking about mechanisms, about the mental process theories. And the task of the mental process theories is to explain as well as possible the functional knowledge. So to explain why it is that those learning effects occur only under those conditions. So why learning has those moderators. That is the task of a good theory. And a good theory is a theory that has a high heuristic value. This means it can explain a lot of functional knowledge. It can explain a lot for why learning occurs under those conditions. And a good theory is also a predictive theory that has high predictive value that can predict new functional knowledge. So the criteria for evaluating a cognitive theory is not truth. It's not about whether a theory is correct. It's about whether the theory is useful. Does it have heuristic value? Does it have predictive value? This is Sokolov. I'll not go into it. It can explain some things, but not a lot. Bradley has a new model. It can explain more. So in that sense, Bradley's model is a better model than Sokolov's. There are models about within each type of learning. There are subtypes of learning, and you typically see that models are created for subtypes of learning, not for the entire class of learning. For example, component process theory is about changes in dynamics of affective reaction. So you have a reaction and then followed by a counter reaction. Okay, so we'll stop here. So classical conditioning, as we said before, is the impact of stimulus pairings on behavior, and you have names for the first stimuli and the second stimuli, CS, US, can all be all kinds of things. There are different types of procedures to study this. Ironically, Pavlov's procedure with the salivation is one of the most well known, but there are hardly any studies that use this procedure. Most use peer conditioning responses where you have skin conductance as a dependent variable or sign. So then the functional knowledge, again, you can manipulate the nature of the stimuli, and that has an effect. For example, the relation between some stimuli is easier, has more impact than the relation between other stimuli. For example, you have taste and illness, taste and taste and becoming sick. Yeah. That has a you only need like one exposure to a taste and becoming sick, you'll get an aversion for it. So that some relations have quicker effect are learned better, and what I mean with learn better is that you need less pairings for the same amount of change. Then there are different types of USs that you could distinguish. You could distinguish between appetitive USs like food and aversive USs like shocks. Again, there is no technical definition for this, but the distinction is often made. What is also important is that the conditions response can be different from the unconditioned response. So typically in textbooks you will see a figure like this. Initially there is a US like food that evokes salivation. Then you pair the CS that initially doesn't evoke that response, but because of the CS-US pairings, CS will now also evoke salivation. So the implicit idea here is that it's basically stimulus substitution. It's now not only the CS can take the place of the US. The CS now evokes also salivation. Now this is a very limited view of classical conditioning, Because, and it's a very wrong view, because in most cases, the conditioned response, so the response, the change in the responding to the CS, is not in the direction of the change of the unconditioned response. Often, for example, if you have, like with an electric shock, the unconditioned response to an electric shock is startle and pain. You see in the animal. But the conditioned response to a light that predicts the shock is freezing. It's the completely opposite of what the reaction to a shock. So the conditioned response and the unconditioned response most often are not the same. So this idea is completely wrong. But you see it. Huh? It is most often not correct. So the type of change you get depends on the type of US. Because there is no correspondence between the conditions response and the unconditioned. So if you have food as a US, you'll get appetitive responses like the tone will start involving salivation. If you have a shock, you'll get defensive conditions responses like freezing. But those conditions responses are not the same as the unconditioned responses. What is also important is that changing the nature of the US also can change conditioning. This is, for example, US evaluation. US evaluation, you have tone followed by food, and then you change the food. Rather than it being an appetitive stimulus, you try to change it into an aversive stimulus. For example, by pairing the food with illness. If you pair a food with illness, the food no longer is appetitive, and as a result, you'll see that also the conditioned response disappears. This is an important phenomenon because it shows that the effect of initial CS-US pairings can be influenced by changes in the US afterwards. Yeah? That's US evaluation. Counter conditioning is very much similar, but you don't change. You don't keep the identity of the US the same. You switch to another US. So rather than using food as a new US, you might use shock as a US. So first you have tone food. As a result of tone food, the tone will evoke salivation. Then you have tone shock. As a result of the tone shock, the tone will no longer evoke salivation. So this is counter conditioning because you have two types of conditioning. First, tone food, then tone shock, and the second conditioning counters the effect of the first conditioning. I can say more about this for Catalina. She's interested in counter conditioning. For me, counter conditioning is much more effective than extinction. Extinction is simply CS-US and then presenting the CS. Because from a propositional point of view, it's about disconfirmation. So counter conditioning is a clear disconfirmation of what happened before. Now it actually contradicts what happened before. First it was followed by something good, now it's followed by something bad. So it is a very strong cue for saying that things in the environment have changed. Now I'm talking at the proposition level. Whereas extinction is a very weak view because there can be all kinds of reasons for why the US might eventually not show up. So in any case, empirically, counter conditioning is a much stronger way of changing conditioned behavior than extinction. But are there other specific things you wanted to know about counter conditioning? Okay, we can talk about this.
Counter condition. I wonder, counter condition is about cell shortness. There are space for the organism looking for STs. So
yes.
It's possible. Is that you could look for exception to the or
that's what you observe. In classical conditioning is not called a stimulus, but an occasion setter. So an occasion setter is a stimulus that signals contingencies. And you have occasion settings. So just like an occasion setter is very similar to an MD, but occasion setter is for classical conditioning. So this is this. So this is US revaluation. And then counter conditioning is, so this is changing, you have the same US food, but you change the affective nature of the US, whereas in counter conditioning, you change the identity of the what you observe also influences, and again, what the type of behavior is a moderator. What is important to emphasize here is that classical conditioning can also lead to changes in voluntary behavior. For example, a pigeon going to one light or another light. A pigeon will move to a light that signals food, even if it reduces the probability of getting the food. So this is called auto-shaping. Why is this for me important? It shows that you don't need to restrict conditioning to involuntary behavior. So that's also why my definition is very broad. Any change in behavior, whether it's voluntary or involuntary, what matters is whether the cause of the change in behavior is the paradox. That's what you have to check here. You don't have to look for the type of behavior, you only have to look for the cause of the change in behavior. Often there are three types of behavior that are distinguished: preparatory or consummatory responses. And these are like freezing to prepare, freezing in order to cope with the shock that comes. It's preparatory. Consummatory is behavior like salivation that helps you to consume the US. So it is basically behavior that prepares you for a future event. And this is most of the time what is studied in conditioning research. But again, important to realize that it's just one possible type of behavior. You can also have other types of behavior. For me, a contingency judgment. So judging on a scale from 1 to 10, how strong is the contingency between the CS and the US? This for me is also a behavior. And this behavior, if this is a function of the actual pairings in the environment, then I will say that the change in contingency judgment is the classically conditioned response. Because I have a behavior, putting a mark on a scale, this behavior is a function of pairings. So that's sufficient for my definition of classical conditioning. So my definition of classical conditioning is the impact of pairings between stimuli on behavior. With contingency judgments, I might have like Mr. X eats lettuce and gets an allergic reaction. Afterwards, and I present this several times in Mr. X eats lettuce, gets an allergic reaction. Then I ask the participant to which extent does lettuce cause an allergic reaction. This is a causal judgment or a contingency judgment. If I see that this judgment is a function of the pairings, so that people give a higher rating when lettuce actually was followed by illness than when lettuce was not followed by illness, then I have a change in behavior, a change in the contingency judgment that is a function of the pairings in the environment. So this is for me classical conditioning.
So in a way, because I see some asymmetry in the way you conceive the functional scientist and the poor Mr. X. In a way, learning by Mr. X is an instance of classical conditioning, but also learning in the science is in the scientist is an instance of.
No, it's so I'm asking the participants to judge the extent to which Mr. X is allergic to lettuce.
Another person judged. I thought Mr. X himself.
So the participant observes this contingency within the context of Mr. X and is asked to judge.
So you would also say that usually correlation is a form of condition.
Well, in that context, if there is an actual contingency that leads to a change in behavior, then I would call it conditioning. If there is no actual contingency, then I wouldn't call it conditioning. But it could be that the illusionary correlation effect is a function of prior pairing or something like that. I don't know. So it depends on, but if there is no regularity, and then there cannot be learning.
But the regularity is that both are atypical, they are less frequent. They share the two things that get together.
So again, there is no real conditioning. It's just how do you analyze this effect. And if you identify a regularity as the cause, then it's learning. If you say it's something else, then it isn't learning. Because it's not, I'm not making a judgment about what is happening inside the person. I'm simply saying learning is the impact of a regularity on behavior. So I need to have a regularity. I, as a researcher, need to be able to identify regularity. And then I need to make the statement that it is this regularity that leads to a change in behavior.
But it is learning in the sense that the group A is the less frequent group, and this group does the less frequent behavior, and then the organism says, okay, group A is more associated with the less frequent behavior, even though the association is not there. So it is a learning.
Yeah.
It seems there is this contingency of what being less frequent and learning.
Again, it depends what you see as the stimulus. So if you consider stimulus to be a context in which behavior A is less frequent, then so you have to assume what is the stimulus for the person who makes the judgment. What is functioning as a stimulus and where is there a regularity? So the repeated, with.
I thought that the stimulus is the whole package that you expose the participant to.
But within a package of events, there you can distinguish many things, and you can see a series of events like presenting a stimulus repeatedly. As I said with the example of Marco, you could also see this as one stimulus.
Yeah.
And yeah, so it really depends on your analysis, on whether something is learning or not. And the only requirements I have to say whether something is learning is that there is a change in behavior, and it needs to be due to a regularity. Again, we'll have to look at, do the analysis and see what for you is the stimulus, whether there is a regularity, and whether this then changes the behavior.
I wonder whether in this way you can reinterpret persuasion effects in the persuasion literature as a kind of a bigger stimulus. So a bigger stimulus which is Mr. X hits Thomas. It's a long story. And then you have something and you ask them to judge their evaluation of this kind of thing. So I guess to what extent at least part of the persuasion literature can be interpreted this way.
Yeah, so that's the whole point. Yeah, so what functional psychology, learning psychology offers you is a pair of glasses to look at reality. And everything you look at, you can try to see, okay, can I understand this in terms of regularities, changing behavior? And if this helps you, good, but that's all it is. It's an analysis. It's a way to analyze what happens in the world. If this helps you to achieve your aims, then it's a good analysis. You will often get discussions about what the best analysis is. What you talk about in terms of persuasion, that's a language behavior, then I think you would need to go to more complex phenomena like arbitrary or responding in order to have suitable analysis. So contingency, so I have a really broad conceptualization of conditioning, because it even includes causal learning, contingency learning. Because through my spectacles, I can see here what the pairings are and what the changes are. And then, of course, development conditioning, again, realize there are very few learning psychologists who have studied this phenomenon. It was picked up in the early 2000s by Ross Fazio and then transported into social cognition. But before that, it's like a handful of learning psychologists who did research on that. And now it's mainly social cognition people who do research on that. So within learning psychology, I don't think you'll often find it even in textbooks. It's not mentioned in textbooks on learning psychology. So it's a very small effect of learning psychology. What is, for me, the difference between development conditioning and peer conditioning is simply the nature of the behavior that you observe. That's why I mentioned it here. You can observe different types of behaviors. Most learning psychologists look at changes in preparatory responses. There was a time when a lot of learning psychologists also look at changes in contingency judgment, and few learning psychologists look at changes in development responses. And the only thing that is unique about development conditioning is that it is a change in a development response due to the pairing. All conditioning are changes in behavior due to pairings. Development conditioning is that subset of conditioning in which you look at changes in development responses. Now, this is already a weak point because I have no criterion of determining what a development response is. There is no technical definition to say this is a development response, that is not a development response. And that's why a lot of people, like learning psychologists, are a bit hesitant to go into this because they are not sure what to do with this distinction between development behavior and non-development behavior. I think it's silly maybe to then simply ignore it. And that's something I think the behaviorists do often. If they cannot fit it in their own concepts, then they ignore it. But that doesn't change the fact that it can be interesting. So,
and the ultimate conditioning is not it's the second type, it's the judgment.
Not necessarily. It can be judgments, but it can also be approach avoidance responses, or whatever you consider to be development response. Then the organism matters a lot. The idea of convergent evolution is a really nice one. So almost every living organism you can identify, most of them show classical conditioning. Now, this is often used as an argument to say classical conditioning is a primitive mechanism, because we see it in all of these different things. But that's thinking of conditioning as a mechanism. We think of conditioning as an effect. So conditioning is the impact, again, of pairings on behavior. This effect you can observe in many organisms. You can observe that in human beings, but also in fruit flies. Now, it is very unlikely for me that the same mechanism is responsible for conditioning in fruit flies than in human beings. Just for me, it's very unlikely. So I don't see why the fact that conditioning is observed in many organisms does not mean that conditioning in humans is based on a primitive mechanism. It could be based on a completely different mechanism that is very complex. So separating conditioning as an effect from conditioning as a mechanism implies that you can have this idea of convergent evolution. For every animal, it is important to adapt behavior to regularities in the environment because it has a very big adaptive function. It means that it increases the chances of adaptation, increases the chances. Adaptation has adaptive effects. There's a difference between adaptation and adaptive, being adaptive. Adaptation simply means the environment influences your behavior. Adaptive means that those changes help you in some way. So adaptation is a functional concept. Adaptiveness is a theological concept. It helps you to do something. Functional simply means your behavior is a function of the environment. Adaptive means it helps you to achieve an aim, namely to reappropriate. So showing conditioning effects is adaptive for every organism. But every organism might reach that effect by different mechanisms. And you can only see this if you separate the conditioning and the effect from conditioning as a mechanism. The broader context can be secondary tasks, and then the nature of the fifth moderator is the characteristic of the pairings. So the word pairing is a very imprecise word. What does it mean to say that you pair stimuli? Does it mean that you present them in space-time contiguity? Is it continuity that matters? Is it the statistical contingency that matters? Does that statistical contingency need to be unique? Or what happens if different stimuli have the same statistical relation to a US? Does that matter? So saying pairings still leaves a lot of room, a lot of things unspecified. And all of this can moderate conditioning effects. So most of conditioning research is about this fifth group of moderators, namely what details of your regularity, how you realize this regularity or the specifics of the regularity, do they influence the effect that you get? And we know initially that contiguity was seen as sufficient and necessary. We know now that we can get conditioning without contiguity, and we know that contiguity is not sufficient. Contingency appears to be important, so it's the statistical relation between the CS and US. Not only do they occur together, but also do they not occur together. So contingency is important, is the logical or statistical dimension. Then conditional contingency is important. And then we get to phenomena like blocking and overshadowing. So if you have overshadowing, you have two between conditions. So this is one condition, AX plus, this means like a tone and a light followed by a shock. And then here, the light alone is followed by the shock. You will see that in this condition, the conditioned response, the peer for the light will be bigger than in that condition. This is referred to as overshadowing condition because it is as if the tone stimulus overshadows the learning of the light-shock relation. That's where the word comes in. Again, this is a bad term because it already implies an explanation for what is happening. The effect as such is simply a moderation of conditioning that adding a second stimulus reduces the strength of conditioning. Impact of an X-US relation is weaker when there is a second stimulus than when there is no second stimulus. This shows that contingency is not the all and everything of learning. It also matters whether other stimuli are present.
So, moderators overshadow?
Yeah.
When is that moderators or moderators?
The salience of A.
Not all stimuli.
So you can have different A stimuli will have different overshadowing effects. Another well-known effect is blocking. Again, two between conditions. The first group first sees A plus trials and then AX plus, and the second group only sees AX plus trials. The conditioned response to X will be weaker in this first group than in the second group. Now, again, the term blocking implies an explanation for this effect, namely that the A plus trials block the learning of the X-US relationship. This is a bad term because the effect as such can simply be described without referring to mechanism. It can be described via the concept of redundancy. In this case, X is a redundant predictor of the US because it doesn't add anything to the predictive value of A. A alone allows you to predict the US. Whenever A is present, the US is present. So X is redundant. It does not add to the predictive value of A. So what I would call the blocking effect, I would call a redundancy effect. And redundancy doesn't refer to a mechanism, it refers to an environmental effect. When a contingency is redundant, you will find weaker effects than contingency. Again, this illustrates how I want to describe everything in functional terms and why I separate theories from theories about mediators from functional knowledge about moderators. In all other textbooks of learning psychology, blocking will be explained in the context of Westola Weiner. But then you leave with the idea that blocking has to do with prediction error. 99% of the people, I think, in psychology think of blocking as a phenomenon related to prediction error. No, blocking has to do with redundancy. And prediction error is one potential explanation of blocking, which is, by the way, not a good explanation. Then you have indirect relations, so you can even have without the pairing and without continuity between CS and the US, you can still find an effect. So this is an overview. Continuity and contingency is more important than continuity. Conditional contingency is more important than contingency. And you can even have effects without continuity or contingency. So these are all about the characteristics of a CS-US relation. But then in an experiment, you can also change the nature of the regularity. And that's a lot of research is about that. So first you have one type of regularity, and then you have another type of regularity. And there are three situations. You can have first no regularity, and then a regularity, or first a regularity, and then no regularity, or the presence of the regularity can depend on the context. Again, this is all about moderators of the nature. To what extent is the nature of the regularity important? More specifically, to what extent the changes in the nature of the regularity also moderate your conditioning effects. Just to emphasize, all about moderators. And this subclass being the nature of the regularity. So first option, no regularity followed by a regularity. You could have first the CS alone and then CS US contingency, or you could have first the US alone and then CS US contingency, or you can have then the second situation is first the regularity, then no regularity, then we have the phenomenon of extinction. So first there are CS US trials, you get an acquisition of a conditioned response, then you break the regularity by presenting the CS alone, you see that the conditioned response disappears, and then an important phenomenon is that extinction disappears over time. So if you simply wait a while, your conditioned response to the CS will reappear, and this is what we call spontaneous recovery. So again, it's not important to know all of this. It's important to realize that these are all studies on the impact of changes in the nature of a regularity as a moderator of classification. Then the regularity can be cued by contextual events, and then you have the phenomenon of occasion setting, what I refer to as an event saying whether there is a regularity or not, and then you get these occasion setting events. So that's all the all the functional knowledge. This is everything we know about moderators of classical conditioning. Again, the task now is for mental theories to explain this functional knowledge, to explain why conditioning is influenced by those moderators. And you have different types of theories. You have associative models. And within associative models, you have SR models and SS models, and then you have proposition models. Again, why is this so important for me to distinguish learning as an effect and the moderators of learning as an effect from the mental mechanisms? Because in other textbooks of learning psychology, people don't discuss propositional models. They are so attached to the idea that learning is the mechanism of association formation. And if you think of learning as association formation, there's no room for propositional models, because conditioning effects that are mediated by propositional representations are not real conditioning effects anymore. If you define real conditioning in terms of association formation, then conditioning effects due to propositions are not real conditioning. That's why I separate this, because this gives me the room to also consider proposition models. For every cognitive model, it's always the task to explain why and how regularities in the environment change behaviors, and they do it in terms of mediating mental processes. These mediating mental processes can be distinguished in 3 steps. The first step is how regularities create representations. What are the conditions under which regularities create representations? That's the first thing any model must explain. The second thing is, what are those representations? What do they involve? And the third thing is, what are the conditions under which associations in memory influence behavior? So every cognitive model of learning has to provide an answer for those 3 questions. The distinction between propositional models and associative models is made in terms of the answer to the second question. Associative models assume that regularities in the environment will produce one type of representations, namely association between nodes in memory. The difference between an SR and an SS associative model is what type of nodes are being associated. SR models say that stimulus response nodes will be associated. SS models say that stimulus and stimulus nodes will be associated. But they both say that what is learned, the representation, is an association between representations. And that what then associative models differ in is under which conditions are those associations formed, what type of associations, SR, SS, and when those associations begin. The SR models were the first models of classical conditioning, and what you often see is that the first theories of a phenomenon often get identified with that phenomenon. So for a long time, and even now, many people think of conditioning as the formation of SR associations. And they really think of the true conditioning, that's the conditioning that involves SR associations. But that's simply because this was the first theory. And often the first theories are the worst theories, because if it's a good theory, people will stop there. The fact that people evolve to other theories means that this first theory is not very good. And if you look at the literature, there is tons of evidence against SR mechanism, up to the level that I would say there is hardly any good evidence for SR-mediated learning in humans. Now, I knew this already when I started my degree in learning psychology, because I had a professor who valued conditioning as an effect. And he grew up in a time when cognitive psychologists were saying, yeah, but there are no SR mechanisms, so conditioning isn't worth anything. There is no evidence for conditioning in humans. The famous Houwer paper in 1947. There is no evidence for SR mechanisms in humans. That's true. But there is a lot of evidence for conditioning effects in humans. So, and then the strange thing is that somehow, despite people like my supervisor Paul Ehlen, and despite people like Bob Rescorla, who wrote many papers saying, look, SR theories is not everything about conditioning. You have conditioning as an effect, can be a complex cognitive phenomenon. Despite these efforts, you still see, and I think you can forgive me this, especially in social psychologists, that they have this really strong idea that conditioning is SR-based. That's why people believe in habits, because habits are SR-based, and that's what they see as the real conditioning. No response to yeah. So what Rescorla and my supervisor did is they promoted, rather than dropping conditioning as a phenomenon because one theory of conditioning is wrong, they switched to another conditioning theory. And that class of theories are SS theories, and now the idea is that CS representation is associated with a US representation. So because they pair are paired. The CS activates the US representation. So hearing the bell makes you think of food, and thinking of food makes you celebrate. That's the idea, and that's why you get US revaluation. If the food becomes aversive, then thinking of the food no longer makes you salivate. So that's a big strength of SS models that they can explain US revaluation. Now, so we basically changed the link. This is here just to illustrate how mechanistic these SR theories are. So basically, you have a conditioned response that somehow evokes a conditioned reaction. Now, in the case of sensory preconditioning, you first have two CSs that are paired, like a tone and a light. What happens then is that there is an association between the tone and the light representation in memory. Afterwards, the light is paired with a shock. You get a light shock, or let's say a light food link. The food evokes salivation. So what happens if you present the tone? The tone makes you think of a tone. Thinking of a tone makes you think of a light. Thinking of a light makes you think of food. Thinking of a food makes you salivate, so you salivate. That's a nice example of mechanistic association thinking. The only thing that happens is the formation of association and the spreading of activation over those associations. To note here, these SS theories also tend to assume that the conditioned response is the same as the unconditioned response, because it's always thinking of the US makes you salivate. So they also don't have a good theory about how the CR can differ from the VR. So it's definitely these SS theories still have problems. Then you have different types of SS theories. You have Rescorla-Wagner as probably the most well-known theory, but the problem with that theory is that it tries to explain everything with assumptions about step one. So for Rescorla-Wagner, every learning phenomena is determined by whether regularities result in the formation of associations or not. It makes no assumption, well, the only assumption it makes about step 3 is whenever there is an association, you'll see a change in behavior. So it is a very stupid model. It just addresses one step. Why two? Okay, it says there are SS associations, and it makes assumptions about when those associations are formed. But it doesn't say anything about step 3. So it's really in hindsight, it's psychologically completely implausible. The only reason why it's been so influential was that it was a formalized model. And it was a formalized model that made interesting new predictions, which is okay, but it's definitely not a correct model. That was clear from the beginning. For example, Rescorla-Wagner predicts that because whenever there is an association, there will be behavior. So the only way to explain extinction is to say that the association disappears. Rescorla-Wagner explained extinction by saying that associations disappear. But we already know from Pavlov that extinguished conditioned responses will spontaneously recover. So from the start, it was clear that Rescorla-Wagner could not explain spontaneous recovery. And Ralph Miller in the 90s wrote a paper, 15 reasons for why Rescorla-Wagner is wrong. There are 15 or more phenomena in learning psychology that Rescorla-Wagner cannot explain. Still, everybody, when they think of learning models, they think of Rescorla-Wagner. So this already should bring across the idea that it's not about whether learning models are correct or not. We don't have models that are correct. The only way I see value in theories is whether they have heuristic value, and Rescorla-Wagner is a really neat, simple idea that allows you to make sense of a lot of findings. Not all findings, but a lot of findings. And it has predictive value L'escola Wagner was useful. It made some unique predictions. So that's why it's still out there. It has heuristic and predictive value. But it's not right. It's not correct. And then people started, so it one of the predictions was blocking, of course, but because of its errors, there were new models developed, like SOP model of Wagner, that assumed not only excitatory associations that are formed, but also inhibitory associations. And then there were future models which said that, okay, so the activity of these inhibitory associations is context dependent, and so on. So you get a series of models that build on each other, where the next model tries to solve a problem of the previous model. But none of them are right. Then you have Miller's model. Miller's model is fundamentally different because it does make assumptions about the third step. So not all differences in conditioning are due to differences in association formation. Miller assumes, and that's what I like very much about the model, Miller assumes you learn everything. But it's only some of that knowledge that sometimes influences your behavior. And that's not an accident because Ralph Miller started as a memory researcher. So his focus was always on retrieving knowledge from memory. Whereas Bob Rescola started really as a learning researcher, and his focus was always on the impact of regularities on knowledge. And you can explain that behavior is always a combination of the two. It's always a combination about acquiring knowledge and using knowledge. So you get these two approaches to explaining learning phenomena because behavior depends on the three steps. And any model that only makes assumptions about one step is lost. And then there is, of course, the propositional models. They are different from associative models because they make different assumptions about the nature of the representation. And different propositional models can be formulated based on when propositions are formed and when propositions are used to guide behavior. But the core is the idea of problem solving. The formation of propositions is an active thing. It's problem solving. You have to actively look for what does the world look like? What are the relations in the world? That's what a propositional theory says. In the mind of the learning person tries to understand the world. I have the impression that the air hole has stopped functioning. So either we can again open the window. Okay. And then finally there is operant conditioning. Then there is operant conditioning. So these are effects of regularities in the presence of stimuli and behavior. I was brought up in more or less cognitive environment, and in cognitive psychology there is an emphasis on classical conditioning. There are reasons for this, I won't go into that, but most behavior analysts mostly look at operant conditioning, because they assume that most behavior is operant conditioning. I have an explanation for this divergence, but it's important to note that if you go to textbooks about cognitive learning psychology, so the mainstream textbooks on learning psychology, you'll get like maybe 50-50 or 60% classical conditioning, 40% operant conditioning. If you go to textbooks in behavior analysis, you'll get like 20% classical conditioning, 10%, and 80% operant conditioning. So, one of the reasons is that cognitive people don't really understand what operant conditioning is. I didn't understand that until 5 years ago. Because cognitive people tend to think of stimuli as isolated events and behavior as the movement of muscles. Whereas a functionalist thinks of stimuli as whatever I call a stimulus, or whatever thing as stimulus functions, and behavior as whatever is a function of its antecedents and consequences. So functional people have a much broader conception of stimuli and behavior. And if you have a much broader conception of that, then you see that most of behavior is operative. Most of behavior is a function of its antecedents and its consequences. So this is the three-term contingency. You can extend this to a four-term contingency, even to a five-term contingency. But the core is the three-term, where there's always a discriminative stimulus that indicates whether a response is followed by an output. So the SD is the discriminative stimulus. It discriminates between situations in which behavior is followed by a result and situations in which behavior is not followed by the result. Hence the name, the discriminative stimulus. The response is the behavior, the SR is the output. And here we now come to, again, an important conceptual point. That is the distinction between the descriptive level and the functional level. I explained this already a bit in Milan during my keynote. And this is a point that I think is also not present in the functional literature, that is underappreciated, this distinction. When I say that there is a stimulus, again, I'm making a claim as a researcher. I'm describing the environment, and it is me who is doing the describing. I'm saying that there are such things, for example, as red stimuli. Red stimuli, like a red circle, a red triangle, and I'm saying red stimuli signal that lever pressing will lead to food. Now, I'm, as a researcher, describing the environment. I'm saying that there are red stimuli, that there is a behavior called pressing a lever, and that there are stimuli that are called food. All of this is descriptive. I'm not yet saying whether the food influences the lever pressing. I'm simply saying that in my procedure, there is a stimulus that signals whether lever pressing is followed by food. This is all descriptive. Right? Now, what is important here is that stimuli and responses are always classes of events. They're never isolated events in space and time. They're always classes. For example, if I say red stimuli signal that lever pressing leads to food, red stimuli is a class of things. And that class is defined by the color. So I, as a researcher, put everything that has a red color within the class, and everything that doesn't have a red color outside of the class. So the stimulus is a class of event. It is a red triangle, it is a red square, it is a red face, whatever. And it's me as a researcher who's making this. So again, important point, at the descriptive level, we talk about descriptive stimulus classes, and each class is delineated by a unit. This unit is the criterion that I use to decide whether something is in the class or outside the class. For example, color can be a unit. The same for responses. Lever pressing is not an isolated movement of my muscles. Lever pressing is defined on the basis of a criterion. That criterion could be that the lever changes its position by 3 centimeters. That is my criterion. So the movement in terms of distance is my criterion for defining lever pressing. I can press a lever with my nose, with my arm, with my whatever. So all of these events would fall within the class of lever. So lever pressing is also always a class of things. Same for food. I, as a researcher who has to define my criterion for saying this is what I consider to be food and this is what I'm not considering to be food. Now, the important thing here is that at that descriptive level, this means I can become really abstract. I can, for example, say my behavior that I'm interested in is imitation. Then the criterion that I use to delineate that class is the correspondence between the behavior of the organism and the behavior of the socius. So you have person A and person B, and it's the correspondence in behavior between the two that is is my criterion for deciding whether the behavior falls in the class of imitation behavior or outside. So now you can definitely see imitation behavior can be anything, even things that have never occurred before. If the other person for the first time does this 3 times and you imitate this is an imitation behavior. It belongs in the class. And same for stimuli. You could have, or a behavior could be a code of things that you enter, or it could even be very abstract things like acting as if two things are the same. And I, as a researcher, can decide, okay, if you say the word glass and I take a glass, I, as a researcher, can say this is an equivalent behavior because I am acting as if the word glass is somehow related to the object glass. And this then fits in the category of behaviors of acting as if the word glass is equivalent to the object glass. I'm saying this because just to give you an idea how far you can go with this idea of behavior as a class and stimuli as a class. It can go everywhere. And if you realize this, then operant conditioning becomes so important. Because you can think of, I as a researcher can think of any type of behavior. Not just the movement of muscles, but also things that are extend over time. Patterns of behavior that are so complex, like acting as if you're neurotic. I can define such a class as a researcher. The only thing I need is a criterion to decide whether the behavior falls in that class or doesn't fall into that class. Then operant conditioning becomes really, really valuable. It's not just about being present. It's about virtually everything that we do as human beings.
Imitation behavior, for example, is something that is just in the mind, in this framework, just in the mind of the functional scientist, not in the mind of the people emitting the behavior.
Everything at the descriptive level is in the mind of the scientist. And then we move to the next level, and that's the functional level. So the functional level is also in the mind of the scientist, but now the scientist is making claims about what is a function of what. He's no longer simply describing the behavior, but is saying the food is functioning as a reinforcer. This means it's because of the lever-press-food relationship that the frequency of behavior increases. So now you are no longer simply describing, now you are relating. And as soon as you start relating your stimulus classes and your behavioral classes, if you start relating them, then you're at the functional level, and then you're no longer saying, for example, right, the light, descriptively you can say this is an SD. This means that procedurally the lever pressing is followed by food only when there is a light. That's the descriptive level. But if you say that the light is functioning as an SD, then you're saying it's because of the light and because of the fact that the light predicts the response-outcome relation. Because of this, the frequency of the behavior increases in the presence of the light. So a functional SD is a stimulus that increases the frequency of a behavior because it signals when the behavior is followed by an outcome. So I'm describing the light not in terms of procedures. Now I'm describing the light in terms of its function. And now I can give you a relatively complex but a very enlightening example, in my opinion, of Catania. Catania is the Bible, in my opinion. Catania 213 is the Bible of the functional approach to learning psychology. And he gives a very clear example of what functions are of stimuli. Because a function not only implies that it has an impact, that's something I only now am starting to realize. Saying that something has a function is not only saying that it has an impact on behavior, it also says why there is an impact on behavior. And now it becomes difficult. So when I say the light is an SD, I say that the light increases the frequency of a behavior. When the light is on, you're more likely to see lever pressing than when the light is on. So the light has an impact on the behavior. But the light has an impact on the behavior, not because it is a reinforcer, because as a reinforcer it should follow the behavior. It has an impact because it precedes the behavior. So that's already a first thing. So this is, when I say this, the light is an SD, I say it influences the behavior because it precedes it. It's an antecedent. I'm even being more specific. I say it's an antecedent that signals when the behavior is followed by an outcome. So when I say that the light functions as an SD, I'm saying that it has an impact because it signals that the behavior will be followed by an outcome. Okay? And that's a really important point. I didn't realize until a couple of weeks ago how important it is. Because I can say, for example, that operant conditioning has occurred. That I can say there's an impact of pairings on behavior. But well, maybe classical conditioning is a better example. So I can say that CS and US pairings have an impact on behavior. But I don't say why. I don't say what is the function of the pairings. So we discussed the other week, yeah? But that maybe is a step too far. But in any case, it's important to realize that the role goes beyond saying there is an impact. It also says why is there an impact.
I don't understand. Is this explanation something that is merely descriptive? If not, how is it different from the cognitive perspective? Because you are still explaining.
Yeah. I'm explaining in terms of environmental events. So every functional relation is an explanation. Because you say there is a change in behavior because of something. Because of something in the environment. And when I'm saying a discriminative stimulus, then I'm saying that there is a change in behavior because the stimulus signals that the response is more likely, that the outcome is more likely afterwards.
But it signals it to the organism.
Yes, but I'm not saying anything that the organism processes. I can do this as a researcher. I can say the probability of the outcome is higher after the response, provided that the light is present.
So you're describing it.
That's describing, and it becomes functional when I say, and it's because of this procedure that I observe change. So I'm always, now I'm explaining behavior. I'm not explaining why it functions as an SD. I'm saying it functions as an SD.
Yeah, but you said that you are explaining, you are giving a why, and I don't see how the why can go beyond the mere description of what is going on without getting in the cognitive.
It doesn't get into cognitive because I don't refer to anything that happens inside the person. I'm only referring to what happens in the environment of the person. But functional level is an explanatory level. It is at one level it's describing, but once you become the descriptive level is purely descriptive. That's separate events. The functional level is relating events. And you can be very specific about what you are relating in those events. Yeah.
Yes, so I see a blind question for the
yeah. So we'll come back to that because I think the pairings can have different functions. And that's the thing. Classical conditioning researchers have never thought about what is the function of pairings. It's strange, huh? I didn't realize it myself until a couple of weeks ago. Voila. It's really, yeah, it's like a complete mind shift once you realize that. And it's strange that we have to, I'm always surprised that in our team, we discuss these types of methods and say, surely people must have thought about these things. And they are so fundamental to what our subject matter is. We're still talking about, okay, what is the best way to think of classical conditioning? for me it's absurd that after more than 100 of years of learning research, we're still thinking about, okay, what is the best way to conceive of classical conditioning. But yeah, this is, I realize I might have gone too far here because it's starting to confuse you. But so the example of Catania is the following. So you have a flashlight, and there is an indicator light on the flashlight. Now the indicating light is likely to function as a discriminative stimulus. Because if the indicator light is red, you're more likely to press the button of the flashlight and then to use the flashlight. Because if the indicator is not on, it means pressing the flashlight will not do. The indicator influences the behavior. It increases the probability of the behavior. But it does so because it signals when pressing the button will make the flashlight. Now, you can also have a flashlight in a dark room or in a light room. You're more likely to press the button of the flashlight in the dark room than in the light room. The room doesn't do this because it signals, it doesn't, the darkness of the room does not signal when pressing the button will produce light. Because regardless of whether you're in a dark room or whether you're in a light room, pressing the button will produce a beam of light. The flashlight will work. So the darkness of the room also influences the likelihood of pressing, but it doesn't do so because it signals the relation. It does so because it influences the extent to which having light functions as a reinforcer. In a dark room, it's important to have light. So you're more likely to press the light because the dark room increases the reinforcing value of having light. And this other thing, so the darkness of the room, is not an SD, but that's what behaviorists call like an enabling condition or an establishing operation. It establishes the reinforcing value of an outcome. And that's a real nice demonstration of how two things can have the same impact. They both increase the probability of pressing the button on a flashlight, but they do it for different reasons. And the function specifies that there is an impact, but also says something about why there is an impact. What exactly in the environment is producing this impact?
I don't understand very well because the function, if I think it as a mathematical function, maybe it's similar. So it's the same. So if there is what the light, room light doesn't press so it's mathematically equivalent. Yeah. Could be mathematically equivalent. How do you discriminate between two?
By specifying what the event is, basically. So I would say behavior is a function of SD, of a descriptive SD, of the fact that it's a stimulus that signals when the behavior will be followed by an outcome. So I would say I don't have it. So first of all, I'll say it's an operant behavior because it's always, as these are always behavior, are always about behaviors that are also a function of their consequences. It's an operant behavior. It's a function of SD. Whereas in the other, I would say the operant behavior is a function of or establishing condition. And then I define these two descriptively. I define an SD as a descriptive stimulus that signals when a response is followed by an outcome. And I define an enabling conditioning functionally. I define this as a stimulus that increases the impact of a reinforcement.
Then I mean, the same in both cases. So
the distinction is how I define these events. I have a different definition for these events.
So it's not the function, the distinction, but it's in your
behavior. So the function can be the same, the impact of this event on behavior can be the same, but the nature of the event is different. And the nature of the event is defined, I can define it descriptively or functionally. It could be like saying it's not the movement of the object is not a function of its mass, but because of the resistance or something like that. Simply identify different things that your behavior is a function of.
So I'm sorry if I stay on this, I don't know if it's okay, but let's stay on the example of the light and the pressing button.
So this is saying the same thing. Exactly. The behavior is a function of the light, or I could even say, the behavior is function of the light, and the behavior is function of darkness. Okay. But then I'm describing light and darkness superficially. This is what I call the light. This is what I call darkness. But I can also define the light and say I'm only focusing on its descriptive properties. I'm focusing on the fact that light signals that the response will be followed by now. So now I'm calling the light SD. Because the light signals when the response is followed by the output. And I'm describing the darkness not in terms of luminance, but in terms of the fact that it can change the reinforcing value of light. And you're right, so it is both functional, but we explain that it's functional differently.
So the only thing I cannot understand is how you bypass the cognitive part.
Where do I refer here to cognitive mechanisms? Where do I make assumptions about what's happening inside the person? It is me as a researcher who's saying the light is an SD. It is me as a researcher saying the darkness changes the reinforcing value.
But then how is this not arbitrary? No.
It's not arbitrary because I can clearly define that the light has descriptively the properties of an SD. And I can test functionally whether the darkness influences the motivation and the reinforcing value of light.
Okay, but you need other equations to do that. Other equations in which this.
Yeah, this is not an issue because that's purely descriptive. I can simply refer to the procedure and say that the light is an SD. I can do this purely, this is descriptive, and I'm referring here, the behavior is a function of this descriptive SD. Here it's a bit more complicated because an enabling condition is defined functionally. I'll have to do other tests to verify that it has this function.
Okay, I understand. So it's not just this function, you need other function, mathematical function in which these two behave differently, and then you have that even though they behave the same here, they're different.
Again, here I don't need to do anything more because this is purely descriptive. Okay. But here I need to do more.
Can I make your life a little more complicated? Nine thoughts. Thoughts. Would that be SD, DC, and you're related to DC? How would you call it? Suppose that I have thoughts, which means if I have, kind of lenses that see in the dark, all of this is less relevant, expanded is relevant. When I say the light, all of this is this an SD or an DC?
Well, it depends, and again, this is not, is this or what is it really? So for the goggles, I would say this is a behavior that is an operant behavior that is a function of seeing. So you want to see, and this behavior is more likely in the dark because then the dark makes it more important. No. Is the darkness then an establishing condition, or is it simply that the elimination of darkness that is the reinforcer? Yeah, so in that case, the elimination of darkness does. But again, everything you can analyze in many ways. That's also important to realize. But yeah, this it shows that it can be useful because you see the same change in behavior. People are more likely to press the flashlight in darkness, and they're more likely to press the flashlight when the indicator light is on. But it is done because there are different functions. This can help you. It can help you discriminate the same thing, what looks as the same thing, and say, no, it's different. Okay, and I'll basically just go. So this is again an illustration how you, with functional definitions, can really distinguish between different types of learning. I'm not going to that. So it's again all hypothesis. There's no reality. These are things, all assumptions that you make, both at the descriptive level and at the functional level. So there are different procedures to use. Again, functional knowledge about the nature of the stimuli, the nature of the response that you observe, then the characteristic of the organism, the broader context. So operant behavior is always not only a consequence of the contingencies involving that behavior, but also the contingencies involving other behavior. Every behavior is a choice behavior. If you do A, you cannot do B. And the choice between behavior A and behavior B is a function of its consequences. And then you can have an analysis of choice behavior and so on. But I don't have the time.
Before going to the end, what is the usual way for humans to do an open conditioning experiment or something like I don't know, blood conditioning to regulating the brains, open conditioning. There are a lot of studies with mouses and dogs and so on. But people.
Well, that I think I can explain with stimulus control. So stimulus control is basically an operant behavior that is in function of its antecedents. So if the light influences my probability of lever pressing, because it signals that when lever pressing is followed by foot, this is called stimulus control. The antecedents control an operant behavior. So if I have this function, I say that stimulus control has occurred. Operant behavior that is a function of its antecedent. Okay? This is stimulus control. Now, different types of events can control operant behavior. Typically, it's an individual event, like a light. Is the light present or not? In this case, we talk about non-relational responding, because you're responding on the basis of a single antecedent. It's the properties of the antecedent that controls your response. Non-relational responding. But your responding can also be controlled by the relation between two stimuli. For example, if two things are identical, then you have to select this one. So here two, they are identical, pick the identical one. This behavior is under the control not only of one stimulus, but by the match between two stimuli. So a relation determines your behavior. If that is the case, if you can demonstrate that behavior is controlled by a relation, then you have relation behavior, which means relation operant behavior. And then this is called a non-arbitrary relation because it is grounded in the physical properties of the stimuli. So this can be the shape, in this case it's identical shape. It can be color, it can be size, it can be anything. But as long as it is the relation between two objects that signal which behavior is appropriate, will give then it is relational behavior, and it's non-arbitrary behavior because the relation is grounded in the physical properties of the events. And then we come to this really annoying but very important concept, which is arbitrarily applicable relational behavior. Because now we have behavior that is still a function of the relation between stimuli. You cannot determine what is the correct response based on any single event. It's always based on two events. So it is relational. Now it is arbitrarily applicable relational because it's not grounded in the physical features of the stimuli. It is grounded in cues in the environment. There are things in the environment telling you which things are related in what way. Now, and these cues can be anything. For example, imagine this training phase. You're reinforced to select this stimulus in the presence of that stimulus. The mere fact that you're reinforced to select the stimulus can act as a cue to respond as if these two are equivalent. There can also be other cues. There can be cues saying like same. Okay, print the word same there. The word same is a cue that we have learned in the past. It tells you these two things are the same. So that's a cue, and afterwards you'll start responding as if these two things are the same. Selection is another cue that we have learned in the past. Selecting one thing in the presence of the other is a cue for them responding to the two as if they are the same. So what does this mean? This means that if I later on present this symbol without any training, people will select this one. Now what does this mean? What they are doing here is they are responding relationally. They're responding on the basis of the relation between those two. But that relation is grounded in contextual cues. It is not grounded in the physical features. It is grounded in the fact that I was reinforced for selecting this one. And then I hope what you mean, that you understand what I mean with its relational behavior. And it is arbitrarily applicable. It's not grounded in physical features. It is grounded in cues. Okay? Now the thing is to think of the behavior. The behavior then becomes no longer selecting a specific stimuli. The behavior becomes this big class of behavior called acting as if this is the same as that. And one instance of that behavior is selecting this in the presence of that. So what I'm doing here is basically signaling to I'm cueing to the participant. This is a cognitive thing, but basically this functions as a cue so that the participants brings to the experiments the class of behaviors of acting as if these two things are the same. The participants knows what it is to act as if two things are the same. The participant knows that if this is the same as that, then if for the first time I'm presented with this situation, acting as if they are equivalent means selecting this one. So the participant, because of this cue, the participant switches to the behavior of acting as if two things are the same. So it's basically, yeah. And now the final step that you have to make is that not only cues like selecting can function as cues, words can function as cues, or the mere pairing of two stimuli can function as a cue. If you see two stimuli together on the screen, people or this can function as a cue for responding to the two stimuli as if they are equivalent. So responding as if the two stimuli are equivalent, you could more or less see this as the behavior like imitation. Imitation is also a very broad class of behaviors, and people can be signaled and say, in this context, I need to imitate. That's one. The same thing here. People in a learning experiment, certain cues will trigger them to start the behavior of acting as if things are the same. It's the same thing as saying cues trigger you to act, to imitate. Imitation is a class of behavior. Acting as if two things are the same is a class of behavior. And both classes of behavior can be triggered by cues in the environment. Now I'm giving a very learning 1.0 analysis of R in F, but I think it's correct, right? Yeah. There's no fundamental distinction between simple operant conditioning and arbitrarily applicable relational responding. Arbitrarily applicable relational responding is simply a very broad class of behavior that can be signaled by cues. Okay, good. Did this make sense?
Is how it's very context dependent our learning methods like this works in the lab and now outside, because being there triggers the fact that you have to act like it's the same, but when you go outside, you don't have this trigger, so you don't do that pairing, and it doesn't generalize basically to some of everyday life because of this mechanism. But the mechanism we are not sure.
So whether cues have a certain function is very context dependent. And indeed, pairings in an experiment could have the function as a cue for equivalence, but outside the experiment might not have a function. Now, I think in real life also, the pairing of things can function as a cue for equivalence, especially in situations that are novel, and people don't have anything else to go on. They will use pairing as a cue for equivalence, but it is important to know that nothing is fixed in the functional world. Everything is contextual dependent. That's also why some people call behaviors contextual behavioral science, because every behavior is contextual. But it is behavior. And now, if you have understood what I've just said, then you can also understand that a very complex behavior like using language is behaving in a way as if things are related. It's behaving as if saying glass is somehow related to the object glass. And then I can have cues for different types of relations. Like glass same as glass. Glass different than bottle. Glass smaller than bottle. And these are all cues that make me behave as if, that make me engage in behavior as if things are related in a certain way. So everything in language can be seen as instances of arbitrarily applicable relational responding. Everything in thinking, because thinking is silent language in your head, can be seen as arbitrarily applicable relational responding. So if you want to influence silent thinking, as we were talking about, think about it as arbitrarily applicable relational responding. And what does this offer you? It offers you the cue that, first of all, it is just acting as if. So you can tell to your patients, your thoughts are not a reality. Your thoughts are a behavior. You're behaving in a particular way. You can change your behavior and don't take it as a reality. Take it simply as something malleable like a behavior. And second of all, we know that any behavior is context dependent, so also verbal behavior, also internal verbal behavior is very context dependent, so you can change it based on contextual cues. And then we have arrived at the point where learning psychology is no longer just about basic forms of learning. We're now talking about language, about thinking, and the whole psychology basically. And that's a good point to end. No? Now at the moment we are preparing a paper, and the title of the paper is Learning as Behavior. Because if you think of this behavior as arbitrary applicable relational responding, and classical conditioning also is that case, then people are not learning a new response. The pairings are not a cause of a change in behavior. The pairings have a function of a contextual cue for arbitrarily applicable relational responding. So then classical conditioning also becomes an instance of arbitrarily applicable responding, and responding is a behavior.
My concern about the relationship with relational responding is that it's difficult to falsify this kind of, because everything is contextual.
Yeah, everything is contextual, and that brings us back to ontology. It's not about whether something is really conditioning, whether something is really R, but to what extent is it useful for you as a researcher to act as if this is R. And it could be the downfall of R. If we don't put any distinctions within R, then we might just everything might collapse. It's possible. But like we have also tried to put distinctions in R'ing, for example, based on what is the nature of the event that functions as a contextual cue. The nature of the event could lead to important differences in the property of R'ing. But this has not yet been examined. So imagine that R'ing is a concept that is now 25 years old, or something like that, and there is maybe in that 20 years, 10 labs in the world that have studied it. So it is really there's so little attention to this concept. That's why even in my lab now, we are doing research on how do you learn contextual cues. How do events acquire the function of a contextual cue? A very important one is how the different cues interact, because in every environment there are multiple cues for relational responding. So which ones will influence you and which ones don't? As far as I know, there's nothing about this. Nothing yet about how different cues interact. So this is, we have a session on the future of conditioning research. Well, for me, the interaction between different cues and how they jointly influence behavior is an obvious future avenue.
So I have future avenue. I think another question that you would have to deal with is how they are categorized at a higher level. The reason that you have is not just the context of that would be falsified, but why some people, why there are relatively stable individual differences in terms of reaction to conflict, which is not part of the async explanation, and why some cues are considered equivalent in the sense of leading to similar reaction, although they are different in the sense of solving. I guess that perhaps another question could be, what is the higher level categorization?
Definitely, and at the moment I would see this as a moderator of all these behaviors and effects is the individual. And that can be the individual at the genetic level, it can be the individual with brain damage or without brain damage. It can also be what you could call personality. You'll have to find some way of classifying these individual differences, and this can be on the basis of different criteria, individual differences. The nature of the organism is a potential moderator of any learning and behavior.
But yes, but here also more one in terms of the categorization of cues. I mean, if everything is contextual, then there is if you go strict on that, then you will have no possibility to be gaps unless you some kind of categorization of cues in similarity, because otherwise it will be messy around. Context is always there is no everything is different from everything else.
Yeah.
So here it will be random in the sense of
Yeah, but remember when I said it's actually the person who brings the person brings a lot into the current context. And what is the person? It's the learning history of that person. So you could have different persons with different learning histories, and they bring with them different, because of their learning history, different events might function in different ways, or they might behave in slightly different ways. So that's a source of stability, is the person, because different persons bring with them different learning. And you could have the other person similar learnings, or person, yeah, as you say, there can be stable differences in the likelihood that Q's will have certain functions for certain. More than enough, I guess. Thank you.